What would happen to Earth if our sun suddenly collapsed into a black hole of the exact same mass? Many people imagine the solar system being sucked into a cosmic drain, but Earth's orbit would remain stable. The gravitational pull stays identical, meaning the planets would keep circling, only now they would be frozen in darkness. A healthy star is locked in a tug-of-war. Core nuclear fusion pushes outward, while immense gravity crushes inward. This balance holds until the star runs out of fuel, fusing elements into iron. The outward push stops, and gravity instantly takes over. Without that outward pressure, the core collapses at a quarter of the speed of light. The star's outer layers are blasted away in a supernova, while the core is compressed into a single, infinitely dense point. A black hole represents the final victory of gravity over matter, an object compressed so tightly that physics as we know it begins to break down. The boundary around this point of mass is called the event horizon. Here, gravity is so extreme that the speed required to escape the object is faster than the speed of light. We can see the silhouette of this boundary in this real photograph of the M87 black hole. Its gravity bends the light from the glowing gas behind it, creating a visible ring around the central void. While stellar mass black holes weigh a few dozen times more than our sun, supermassive black holes are millions to billions of times heavier. Scientists find these giants anchored at the center of almost every galaxy, including the Milky Way. These objects serve as the central anchors for their galaxies, providing the gravitational framework that holds trillions of stars in stable orbit. Black holes do not actively hunt down matter across the galaxy. Matter is only consumed if it physically crosses the threshold of the event horizon. If you were to cross that threshold feet first, you would experience a violent physical process known as spaghettification. Because your feet are closer to the center, gravity pulls stronger at your lower body. Simultaneously, it pulls your sides inward. You are stretched vertically and crushed horizontally, pulled into a thread of atoms plunging toward the center. Inside that singularity, physical identity completely disappears. Whether the matter was a planet, a cloud of gas, or a star, everything is crushed into an indistinguishable clump. Falling into a black hole results in the absolute erasure of an object's physical history. From the outside, the only measurable properties that remain are mass, electric charge, and spin. Advance the clock trillions of years into the future, and the universe enters a dark era. After the last stars burn out, black holes will be the only massive objects remaining. In 1974, physicist Stephen Hawking proved that these cosmic traps are not actually eternal. The explanation lies in the rules of quantum mechanics. Empty space is constantly bubbling with pairs of virtual particles that pop into existence and then instantly destroy each other. When particle pairs appear on the event horizon, gravity separates them. One gets pulled in, its partner shoots into space. Because this escaping particle carries energy away, the black hole loses mass and slowly shrinks. Even the most massive objects in the cosmos are destined to evaporate, slowly bleeding mass into space through these microscopic quantum leaks. This evaporation process is slow. For a supermassive black hole, it takes up to a Google years to fully decay. But the process accelerates. As it sheds mass, the escaping radiation burns hotter and faster. In its final fraction of a second, the dying black hole explodes, unleashing the energy of billions of nuclear weapons. This death creates the ultimate information paradox. If matter is destroyed and the black hole itself vanishes, what happens to the fundamental quantum records of everything it ever consumed? Physicists still don't know. The evaporation of the last black hole leaves the universe in a state of absolute thermodynamic equilibrium, a cold, dark expanse where no further energy can be exchanged and no life can survive.